This section is about transformations of functions, and the simplest kind of transformation to understand is the vertical shift. So here we have the function f of x equals x, or the square root of x plus 1. So the basic function here is the square root of x function. So we imagine that this is our graph for the square root of x. Now, the square root of x is a y value, and so now we want to graph the square root of x, which is our y value, plus 1. So in particular, the y value for this point, which is 0, is going to be increased by 1. The x value will stay the same. So in other words, the graph will be shifted up 1 unit on the y-axis, just like that. So that's how you transform the graph with a vertical transformation. So this is called a vertical shift 1 unit. And you can say up if you want, but 1 unit is sufficient. Now, the next one, f of x equals x squared minus 1. Let's clean this up a bit. F of x equals x squared minus 1. So the basic graph here is f of x equals x squared, so we start with that. F of x equals x squared is a parabola. And now what we see is x squared here is going to become x squared minus 1. So x squared is a y-coordinate, so the y-coordinates would all be shifted down 1 unit. So in particular, the y-coordinate of this point is going to shift down 1 unit, and so we'll now be at negative 1. That, and so now we have x squared minus 1, and for future reference, the x-intercepts are the values where x squared minus 1 is equal to 0, x squared minus 1 equals 0, if x equals plus or minus 1. So this is negative 1 here, and this is positive 1 there, and this is negative 1 on the y-axis. So this is a vertical shift down, 1 unit. 1 unit. Okay. So shifting graphs horizontally is probably the next easiest type of transformation to understand. So first we have x minus 5 squared. The basic graph is x squared. So we start with that. So there's the approximate graph of x squared. It goes to the 0, 0 right here. Now this is x squared. Now, what happens to the x-intercept when you have x minus 5 squared? Remember, the x-intercept is the value of x that makes x minus 5 squared equal to, let's see, where the x-intercepts, equal to 0. And so that happens when x equals 5. So 5, 0 is the new x-intercept. So the graph actually shifts to the right. Shifts right 5 units. So the new graph is going to have x-intercept right here at 5, 0. And the y-intercept is when x equals 0. So the y-intercept is 0 minus 5 squared, which is 25. So let's just say that's 25. And so we get the graph. Something like that. So you can study horizontal shifts of graphs as adding a constant or subtracting a constant, and the graph shifts depending on what constant you're adding. This one is 2 shifts are happening. The first shift is a horizontal shift 3 units to the right. So we start with the graph of x squared. That's the graph of x squared. And now we shift horizontally. Let's see, horizontally 3 units to the right. And when we do that, we get vertex here at 3, and then the y-intercept of x minus 3 squared is 9, so that would be 9 right there. That's what you get when x equals 0. And then we want to add 5. That's the next shift. That's a vertical shift, 5 units. Okay, so now we have to shift this graph 5 units. So we'll take x minus 3 squared and add 5. So, in particular, this point, which is at 3, 0, will end up at 3, 5. So here's 3, and that was our 9 right there. 3, 5 is going to be about right there. And this point, which was at 9, is going to also shift 5 units upwards, so that's going to end up at 14. Something like that. And then the graph is going to be like that. So that's 2 shifts. Okay, so then the next kind of transformation is a reflection. So here we have the first type of reflection. Notice that this is a reflection of the y-coordinate, because if the basic graph is x cubed, here's the basic graph, x cubed. Now we want to graph the opposite of x cubed. That means we're taking x cubed and multiplying it times -1, and x cubed is a y value. So each y value is multiplied by -1. So if that y value at that point is multiplied by -1, the new point ends up down here. And the y value for this point multiplied by -1 means that the new y value ends up right here. And so on. So each y value ends up crossing the x-axis. Similarly, these y values go up to the other side of the x-axis. So the graph is going to look like this. It's called a reflection. Reflection across the y-axis. Reflection across the y-axis. This next one is a reflection as well, but it's a reflection across the x-axis. So to see that, you can examine the graph of the fourth root of x. Fourth root functions look like this, and it starts at 0, 0. So that's the fourth root of x. Now if you want to do the fourth root of the opposite of x, that means that now you have to use negative values of x. So what that means is that every x here will then become the opposite of x here. So for example, the x that is right here for this point will be opposite, will be over here. And the x that's for this point will be opposite, and it'll be over there, and so on. So what's going to happen is the graph reflects across the y-axis. And I think that in the previous one I said x-axis, and I think I said y-axis right here. I meant to say x-axis, so let's fix that. That's a reflection across the x-axis. See, these lines are all going across the x-axis. That was just a momentary lapse. So this is a reflection across the y-axis. That's what made me realize I had done it wrong before. This is a reflection across the y-axis. So I hope that didn't confuse you too much. Reflection across the y-axis. Just a little rewind and go back. So remember, that's across the y-axis, and this is a reflection across the x-axis. You have your general rule, which you can study. The next type of transformation is the stretch and shrink in a vertical direction. So when you're stretching or shrinking in a vertical direction, you think of the graph as being anchored on the x-axis. And so if the graph is like this, and you imagine that you're grabbing hold of it right here at this point, and you're just going to pull it up, what it's going to end up looking like then is stretched. So that's a vertical stretch. Now, if instead of pulling on it, you push down on it, if instead of pulling on it, you push down on it like that, then what's going to happen is the graph is going to end up being like that. It's going to be flattened out. So the way to know which one's happening is to look at what number you're actually multiplying by. If you're multiplying by a constant that's greater than 1, then it's going to be a vertical stretch. If you're multiplying by a constant that's between 0 and 1, then it's going to be a vertical shrink. Vertical shrink. Now, in this one then, it's going to be a vertical shrink of y equals x squared. So you start with x squared. Start with x squared. And what you realize is that for 1/4 of x squared, for example, this point here is at a height of x squared. So 1/4 of that is going to actually be lower. 1/4 of that is going to be right down here. So the new point is going to be down there. For this point, you have a height of that much. The new point is going to just be about right there. So you see what's happening is these points are all getting flattened down. So the 1/4 of x squared graph is going to look like that. Notice that the x-intercept stays the same. But when you multiply by a number greater than 1, like for this one, the absolute value, 3 times the absolute value of x, the basic graph is the absolute value of x. When you multiply times 3 then, for example, this point has a height that's the absolute value of x, so 3 times that is actually going to be up here. So each point on this graph is going to go 3 units higher, so the new graph is going to be like this. So that's a stretch. That's a vertical stretch. So here's the rule. You can also find that in your textbook. And then we did one that was a combination. So for this one, what you should do is first, you should shift to the right 1 unit, the graph of x squared. So here's x squared. So first we shift to the right 1 unit. That means we're going to now be here at 0, 1, or 1, 0. Then we're going to multiply times a half. That means it's going to flatten it out. So we flatten it out a bit. Then we'll multiply times a negative. That means we're going to reflect across the, let's see, the negative of that, the negative of the y's. So we have to reflect across the x-axis. That. And then we have to add 3. So the final thing that we'll do is raise it up 3 units on the y-axis. So it's going to end up looking like that. So that was pretty fast. You should be able to follow that. Okay, so for this one, we're going to sketch the graphs of these. So this is the function f pictured, and we want to sketch the graph of f of x minus 2. Now, x minus 2 will shift this graph to the right 2 units. And so f of x minus 2 is going to look like this. 0 will be 0, 0 will be shifted to 2, 0. This peak up here is going to be shifted over 2 units, so it's going to be here. And the other bottom part on the x-axis there is going to be shifted over to here, so the graph is going to look like that. Shifted over 2 units to the right. Okay, the next one is f of x minus 2. That's a vertical shift down 2 units. So, vertical shift down 2 units. We'll put the peak here, and we'll put these other points like that and like that. So here's your f of x minus 2. Okay, 2 times f of x. 2 times f of x means that each function value will be twice as high. F of x is a function value, it's a y value, so 2 times the y's. So that's going to keep this one in the same spot because y there is 0, but this one here is going to move up twice as high as it is. So it's going to actually get stretched to way up here. And that one again has a y coordinate of 0, so that one's going to stay. So this actually just gets doubled in height. So that's what that one is going to do. Let's see, the next one is minus of f of x plus 3. So minus of f of x, that, oh, sorry about that. Okay, minus of f of x, this here, is going to take this graph and reflect it across the x-axis, and then plus 3 is going to lift it up 3 units, so it's going to be like that. And you can figure out what those actual endpoints are. I'm just trying to get you quickly through this. The next one is f of the negative of x, and that's going to be a reflection across the y-axis, like this. And then I'll let you do that one on your own because I'm running out of time here. Okay, we did this one extensively in class, so I just want to remind you that this one is a shrink on the horizontal axis of 2 units. So the new graph is going to be like this, and then I can't remember exactly where it goes, but it's sort of like this. It goes below, and then it comes back above. It's like a shrink of a factor of 2. That's 6, so it should go to 3. It should go to 3 right here. So that's what it's going to look like. And then for g of x equals 1/2 x, that's a stretch of 2. So what happens there is this goes to, I think it goes like this, and then it goes something like that, and it goes up like that. So it's a stretch out of by a factor of 2. And then to determine whether they're even or odd, remember you have to calculate f of the negative of x. Okay, if f of the negative of x is equal to f of x, then the function is even. And if f of the negative of x is the opposite of f of x, then the function is odd. If neither of these is true, then the function is neither. So for this one, f of the negative of x equals the negative of x to the 4th power, and since that's 4 factors of negative x, that's the same as x to the 4th power, and that's f of x, therefore the function is even. The next one is neither. If you do f of the negative of x, you get the negative of x squared plus the negative of x, which is equal to x squared minus x, which does not equal f of x, and also does not equal f of the negative of x. I'm sorry, the negative of f of x. And so therefore the function is neither even nor odd. But this one, if you look at f of the negative of x, that's equal to the negative of x cubed minus the negative of x. Now the negative of x cubed, since there are 3 negatives, will be the same as just negative x cubed. The next term is plus x, and that is equal to the opposite of x cubed minus x, which is the opposite of f of x. And since f of the negative of x is equal to the opposite of f of x, we have that the function is odd.